questions from the practice exam questions. So goal is to finish these off tonight, so we'll see how we do. I notice I ran out of space a little bit here, so I'm going to transition over here to white paper. All right, so our goal here is, it's an algebra question. We're trying to find a value of a variable, in this case it's the theta, within the interval from 0 to 2 pi. So that means we're going to be solving for angles in radians. All right, and so to solve a question like this, we got 2 times sine of some value minus 1 is 0. And so what we want to do in general, let's write out some steps here. Okay, so I'm going to write out 2 sine theta minus 1 equals 0. So stage 1 should be to isolate the trig ratio. Okay, so that means we're going to treat this sine theta kind of like an x. We're not going to isolate theta itself right now. And the reason for that is actually there's 2 answers, but if we try to just use algebraic rules by kind of doing opposite operations to both sides to isolate theta, we're only going to end up getting one of the solutions, but we want both or all of the possible solutions. So what we'll do is, we will add 1 to both sides of the equation. Add 1, add 1. And so it's going to cancel this guy out, and we'll get 2 sine theta equals 1. Then we're going to divide by 2 to cancel out this multiply by 2. Opposite operation again. And so that tells us that sine theta is a half. All right. I'm going to zoom in a little bit here. I think maybe we're zoomed out just a touch, so it'll be easier. So if you're watching it on your phone or something, it's not a writing for ants. Okay, so that's step 1. We've isolated the ratio. Sine theta is 1 over 2. Okay, cool. So what that means is we are going to be having some sort of right angle triangle, and the opposite is 1, and hypotenuse is 2, because that's what sine means. That's going to be the opposite over the hypotenuse. Okay, so step 2 is we want to sketch the triangle that fits the ratio in what we call standard position. All right, so what that means is we're going to draw out some axes. And we know this is 0 radians and pi over 2 radians, pi, 3 pi over 2 radians, and 2 pi. Okay, so we know we're going to have an opposite value of 1. So, okay, and a hypotenuse of 2. So I can draw a triangle in this quadrant that has an opposite value of 1 and hypotenuse of 2. I can also sketch the similar one in this quadrant. Now, we had some memory devices for remembering which quadrants we could draw particular trig ratios in. So we know that this sine theta equals 1/2. That means that the sine value, the sine ratio, is positive. And so that means if we think about either maybe you knew CAST as a memory device, or you learned all students take calculus, or Ali and Scott are table companions if you're in my class, then you know that this means that all of our ratios are positive. Only the sine ratio is positive. Only the tan ratio is positive. Only the cosine ratio is positive. So that means we can be in quadrant 1 or 2 for this ratio. Okay. Now, lastly, we want to see if we can fit a special triangle to this. And it turns out we can. This is congruent to the special triangle 1, 2, root 3. We have a right angle here. And if we filled in these angles here, we got pi over 6 and pi thirds. Okay. So that means that the angle opposite 1 is pi by 6. And this reference angle here is also pi over 6. All right, now where's my red pen? Okay, I'll use blue then, I guess. Okay, and so then we've got our two angles. Angle 1 terminates on this terminal arm, and angle 2 is going to terminate here. Okay, so step 3 is we're going to express our angles. Okay, so that gives us theta 1 is pi over 6, and theta 2 is, well, looks like it's almost at pi. Then we're going to take away that part we're missing, that pi over 6. So I'm going to write that as pi minus pi over 6, which is to say that's 6 pi over 6 if I wrote them with the same denominator, which means we have 5 pi over 6. All right, and that's equal to theta 2. That's one answer, and that's the other answer. Now, if you wanted, we can do an optional step. I'm not going to do this for all of them, but I would encourage you to. We can check our answers, right? We can say, okay, if that's true, then if I put that in for theta in the original question, 2 times sine of pi over 6 minus 1 has to be equal to 0. It must also be true that 2 sine of 5 pi over 6 minus 1 equals 0, right? And in my special triangle, I can see that sine, or opposite over hypotenuse, of pi over 6 is a half. So that means 2 times 1/2 minus 1 equals 0. And 2 halves, so that means 1 minus 1 is 0. And that's true. That means that our answer, pi by 6 for theta, is a true solution to the equation 2 sine theta minus 1 is 0. We're looking for values of theta that make it a true statement. Lastly, I could do that with this one. So 2 times sine of 5 pi by 6. So if I look at the angle 5 pi over 6, and I've got an opposite of 1 over 2. So again, I'm going to be putting opposite over hypotenuse of 1 over 2, pardon me. So we're going to replace this guy with 1/2 opposite of 5 pi by 6 over hypotenuse minus 1 is 0, and I get the same expressions. This is also true. Okay. So this is a step that you can do if you want for every one of these questions. Alternatively, you could also do that with a calculator, right? You don't have to write all that out. In fact, this might be a better way to test because it's in some ways we were kind of using the same work we did before to check if this was correct. So in some way that's kind of disingenuous. So I'm just going to turn my calculator to radians, and I'm just going to type 2 sine pi by 6. Where's my pi button on this calculator? No, it's a second function of this guy. Pi divided by 6, and I'll take away 1. It gives me 0. Okay, that's what I want. That means this must be correct. And you can test the other one by yourself. All right, let's move on. Hopefully this one takes less than 10 minutes. All right, I guess the last one took slightly less than 10 minutes. All right, so we'll try and speed up this process a little bit. Okay, so step 1, we're going to isolate our trig ratio. Okay, so we'll take away 1 from both sides, and that's going to give us root 2 cos theta is equal to -1. And then we'll divide by root 2, divide by root 2. And that gives us cosine theta is -1 over root 2. Okay, so there's our trig ratio isolated. And now cosine is negative. Okay, so what quadrants can we be in here? If we think about all students take calculus, if cosine is negative, we're not going to be in this quadrant because everything's positive in this quadrant. Only sine is positive, meaning cosine is negative. Okay, so that's good. only tan is positive in this quadrant, meaning cosine's negative, and cosine is positive, so it's not going to be here. Okay, so second we're going to sketch this triangle in standard position. So I like to label up my axes so I never forget kind of where we are. All right, and we said it's going to be in the second and the third quadrant. I never noticed that S and T also correspond to second and third. That's kind of interesting. All right, so I've got some angle. I'm not going to worry too much about what the triangle looks like because we can operate under the assumption we don't know exactly what this triangle looks like, even though if you recognize these numbers, you might actually recognize it is a particular triangle with a particular ratio. Anyhow, our adjacent, because we're in cosine, is -1. So we got -1 here, and our hypotenuse is always positive, and it's √2. And that might look like a triangle you've seen before, and you're going to find they generally do. And that's our third quadrant one. Same adjacent, but the hypotenuse is √2 down here. And again, even though we're in this quadrant, hypotenuses are always positive. And you might recognize this is a 1, 1, √2 triangle, meaning our reference angles are pi/4, which corresponds to 45 degrees. All right. So then we're going to say, okay, well, what angles take us there? So we have one angle here, which I'll call θ1, and another angle here, which I'm going to rainbow over and call θ2. Okay. So θ1, it looks like, is almost at pi, but we're missing a quarter of pi to get there, so I can take away pi/4 from pi to find our value. And if I change the denominator of pi/1 to be denominator 4, it'll be 4 pi/4 minus pi/4, which is going to give me 3 pi/4. Okay, and that's θ1. And θ2, well, that's going to be like pi radians plus a little bit more, a quarter of pi more. So it's going to be 1 pi and then 1/4 of pi, or 1 1/4 of pi. So if I have pi quarters and I add it to pi, it's like saying 4 pi/4 plus pi/4, which gives me 5 pi/4. And I hope that makes sense based on the idea that we have one whole and then a quarter more. That's like saying 1 1/4 of pi, or 5/4 of pi. Okay. Now, we talked about checking, and that's optional, but you can do that yourself. I invite you to type that in for cosine. Punch this whole thing into a calculator. √2 times cosine of your angle, 3 pi/4, take or add 1 and make sure that gives you 0. And that's a good way to test to make sure your answers are both correct. And that's something you can do on a test to make sure your answer is correct. All right. Oh, that one went a lot faster. Okay, cool. Last question here. √3 over 1/3. That's weird. Wait, what? √3 over 3. Oh, that's interesting. Okay. I guess I should label 13C. I got about 13B. Okay. So we've got 3 tan theta plus √3 equal to 0. Okay. So we're going to do step 1, which is we're going to draw this guy out, or isolate the tan ratio. And so I'm actually going to skip a few steps here. I think you can probably take away √3 and then divide by 3 yourself. And you guys have done that enough in your math career to recognize that that's probably where we're going to get here eventually. I hope I didn't do that too quickly. Okay, so that's interesting. So what's this going to look like? So that's a negative tan ratio. So if we think about all students take calculus, negative tan ratio, that's going to be here and here, because it's not going to be here because tan's positive here and they're all positive here. All right, so second is we should probably draw it. 0. pi by 2, pi, 3 pi over 2, and 2 pi. Okay. And so we have some angle. It's going to be in here. So I don't know what this triangle looks like, so I'm just going to draw it. And I have some angle theta that's going to go here, theta 1. And it looks like tan, let's remember, is the opposite over the adjacent. So that means the opposite is going to be root 3. And the adjacent in this case is going to be negative 3. Okay. And that'll be the same over here. And actually, I think I realize now that I labeled it up that actually that was not really to scale, which doesn't really matter. But for my next one, I'm going to try and draw it a little bit more to scale, because I know 3 is bigger than root 3. So I'm going to have an adjacent of positive root 3 in this case, and an opposite of negative root 3, and an adjacent of 3. Okay. So this is an interesting situation. This angle here is not an angle that's in one of our special triangles. Okay, so what are we going to do? Well, in this case, we can just use the inverse ratio for tan. We're going to tan negative 1, or inverse tan, or arctan, both sides of this equation. And you may remember this from grade 11. This is a grade 11 move. And so we're going to cancel out tan and solve for, this is going to solve for our reference angle, of course, not for theta 1. This will solve for our reference angle. And it's going to be equal to the inverse tan of root 3, negative root 3 divided by 3. And it's some weird value, it's 0.52 radians. Or 0.54, I guess I should say, radians. And that's how big our reference angle is here. So that's going to be 0.524 radians. And this guy, I'll try it over here so it's not clumping up. So we get theta equals 0.524 radians. Now, so that means we're going to have theta 1 is going to be a little bit less than pi. It's going to be 0.524 radians less than pi, so pi minus 0.524 radians. That's radians as well, of course. So it'll be pi minus 0.524, which will be 2.62 radians. And I should put approximately, because we rounded there. Turns out we're not going to give an exact value for this theta, in the same way that we were for the other ones. And theta 2 is going to be approximately 2 pi minus that same value here, because that's going to be our theta 2. Looks like 2 pi radians, take away this 0.524 radians. 0.524 radians, which is going to be approximately equal to 2 pi minus 0.524, 5.76 radians. So that's a little weird there. That's okay. That's our step 3, of course. And step 4 is you can check. So actually you're going to find if you punch in either of these, because they're slightly rounded, when you punch them into your original equation, you're going to find you get a value that is almost 0, but not quite 0. So let's move on. What do we got next? 14. Okay, so there, I think we can write directly onto here. So we're going to So I want to remind you guys that in an equation like this, y equals a for amplitude times a sine or a cosine, and we get a b value which is related to the period but not the period, and x minus our phase shift plus our vertical shift. Okay, so our amplitude is always this first term, and it's the positive value of that first term. So if this was a negative 2, our amplitude would still be 2, even if it said negative 2 sine. Now the period, you want to remember that the period is related to b, but it is not the same thing as b. So period is not 1/2. Period is 2 pi divided by 1/2. Now, dividing by 1/2 is the same thing as multiplying by 2. We learned that when we learned about dividing fractions. We flip and multiply, right? So 2 pi divided by 1/2 is the same thing as 2 pi times 2 over 1, or 2. So that means our period is 4 pi. Our phase shift is this value here, and now you remember that when we take away a negative value, that simplifies to get a positive value inside this equation. So that means our phase shift is actually negative pi over 3, meaning this graph will be shifted pi by 3 radians to the left. Our vertical shift is this value here, so our k value is negative 4. The domain of any trigonometric function that is not restricted in any way is all real numbers. So x such that, squiggly line, x such that x belongs to the reals. Now, if you picture this graph, it's going to look something like this, where it's got a domain of 2, but it's been shifted down, it's got an amplitude of 2, but it's been shifted down 4. So it's going to go up, have a midline, y equals 4, negative 4. Now we'll be going up 2 and then down 2. So you can think of it looking something like this, where that goes up to negative 2 and down to negative 6. Okay, so the range will be y such that negative 6 is less than or equal to y, which is less than or equal to negative 2. And y belongs to the reals. Okay. And if you weren't sure about that range, I would invite you to sketch that graph a little bit more carefully, review how to sketch these guys, and you'll be convinced that that's the domain. Pardon me, the range. All right, now we're going to do the reverse. We've got this equation, and we're going to look to express its amplitude, its period, and then we're going to convert that to a value of like this letter b that occupies a term that expresses the period, phase shift, and our vertical shift here. All right. So the way we talked about doing this is to start with a general function, y equals a, and we're not even going to choose if we're going to use sine or cosine yet. We're going to choose that later. And we'll write in all of our variables, and we're going to go one step at a time. Okay. So we talked about some values that were easier to find than others. So it's good to identify maybe a middle line, the sort of the highest point, the max, and the min. So the max here looks like it's at 4, and the minimum's at negative 2. And if I take my maximum and I subtract my minimum, and I divide that by 2, I should get the amplitude. So the amplitude is the max minus the min divided by 2. Now, if you want to get fussy, actually it's the absolute value of this. Because if your max was negative and you took away negative min, you would still... Wait, hang on. Would that actually cancel out? You would actually... Maybe you don't need those absolute value signs. All right. I need to think about that more carefully some other day. Okay, so our max is 4, and we're going to take away negative 2, and then we're going to divide that all by 2. So it's going to give us 6 over 2, which is 3. So that means we can rewrite this equation. And we're going to rewrite it with a 3 in place of a. 3. And we'll still leave a sine slash cosine, and we'll choose that later. Bx minus phi plus k. Okay. And so that's maybe, we can think of that being step 1. All right, we find our amplitude. Now, the k value, the vertical shift, is often quite easy. So that's kind of similar. It's the average of the max and the min. So our k value is always the average of the highest and the lowest point. It's going to be right in the middle. So that means max plus min over 2, the average. Okay, and so it's going to be 6 plus negative 2 divided by 2. Or pardon me, 4 plus negative 2 divided by 2, which is 2 over 2, which is 1. And that's our k value. And so that means we can rewrite this equation again. So we're going to y equals, and I'll write in 3 sine slash cosine bx minus phi, and we'll say plus 1. Okay, so we're about halfway there, but not quite, because we also have to figure out what sine and cosine are. All right, so we did 2 steps. Now, the next thing to do might be to look at the period. How long does this thing take to repeat? So you might go peak to peak. So you were looking for x values. And so I can see that it takes exactly pi units for 1 period to pass. And so you can think of the, if we go, so we look and say that's pi for this value of x, take away 0. Oh, right, so I'm going to label that. We're going to find our period. Our period, we can go peak to peak if we want. And we're only looking at the x values. Okay, so, and we can take peak 1, and we'll take away peak 2, and we'll just subtract them. That should give us our period. All right, and so I'll say, well, this is the point pi 4, and that's the point 0, 4, and those are near peaks. And so to go from one to the next, you might say that's going to be pi, and we're going to take away 0, so overall it's going to give us pi. So our period is pi, but that's not what we need. We need a b value, so our b is related to our period by this equation, 2 pi over the period. And so that means we're going to have 2 pi over pi, or 2. So our b value is 2. So then I can rewrite that equation again. So it's going to be y equals, and I'm just going to keep it in black here, sine or cosine. And now I'm going to write the value 2 in here instead of b. And the last thing to do is to figure out what our phi is, and also if we should be using sine or cosine. Now, the reason I left sine or cosine to last is because depending on the value of phi we choose, it may be easier or harder to, I think I said that backwards actually now that I think about it. Depending on whether we want to express this using a sine function or a cosine function, that's going to affect our value of phi. And if we're sneaky about it, we can choose a sine or a cosine such that our phi will be 0. We can't always do that, but sometimes we can. And so when it comes to phi, our phase shift, we got to remember a few things. We want to remember that a positive sine curve kind of starts in the middle of its upward part of its face. Okay, so it starts sort of in the middle. So if our curve kind of starts when it passes the y-axis, sort of in the middle, in between its max and its min, sort of halfway, maybe we want to use a positive sign, especially if it's moving upward after the y-axis. Otherwise, we might want to use a negative sine graph, because that's when it would be passing downward, but also in the kind of the middle of its face. So we could also think about a positive cosine graph, and that starts at the top of its period, so it starts up like that. And so if our graph starts at the top of its curve at a max, at a peak, then we might want a positive cosine graph, and a negative cosine graph starts at a trough, starts at the very bottom, at least if we think of starting being at the y-axis. And so those are some key graphs we want to choose here. And if we look at this graph, we see it starts at the peak. And so if we make this a positive cosine function, we say y equals 3, and just cos this time. And that says, in that case, if it's starting right here, it's not really moved left or right. Our phi value, our phase shift, is 0. That means we can really sum this up as saying just, I wanted green. Not that it really turns up that much differently in these videos. 2x plus 1, and we're done. Now, if you wrote this as a sine curve, or there's actually many different answers that would be equivalent to this equation. If you solved and you got a different answer than this, say you did sine of 2x minus pi and a half or something like that, plus 1. What I suggest you do is punch this equation into Desmos, then punch your equation into Desmos, and if they overlap perfectly, it means that your answer was an equivalent answer that was just as fine as mine, and you made some different choices about maybe whether you sine or cosine, or maybe you use cosine but thought about it starting over here or something like that, and therefore it had been shifted pi units to the right. That's fine. There are many correct answers to this. This is just one. Okay. So let's see what else we got here. All right, so sketch at least one full cycle of the graph. Y equals -3 cosine of pi theta plus 2. Okay. So what do we need to know? We need to know, well, it's got a lot of variables here. I think maybe I kind of want to start with the midline. So I think the k value is a good one to start with. Our k value is 2. So that translates usually to what we think of as a midline. Okay, so that means no matter what, our graph is kind of be centered around, in the vertical sense, the y value of 2. So I'm going to sketch that. I'm going to sketch over here. And it says sketch, not like draw on a grid. So actually, you know what? I think I'm going to start a little slower because I have a hypothesis. I said slower, I meant lower. I kind of know what this is going to look like a little bit. I know I want to leave a little bit more space here. I know that because my midline is 2. So I know that the graph is going to sort of go through the line y equals 2 like that. And it's going to be kind of half of it's going to be above it, half of it's going to be below it. Okay, so I know that much. I might also find out what my max and my min are. So I know my amplitude is 3. So that means my graph is going to rise 3 units above the midline and 3 units below the midline. Okay, so that means, so our max is going to be k plus a, and so that's going to be 2 plus 3, 5. So we're going to have a maximum value of 5, so it's going to go upward to 5. So I'm going to draw that one there. And I know my minimum value is going to be k minus a. Our midline take away the amount that our graph differs from the midline. So it's going to be 2 minus 3, or -1. So that means it's going to go all the way down to -1. Okay. And I might label this 1, 2, 3, 4, just to give some scale. All right, now that's fine, great. What else we got here? It looks like we've got a negative cosine graph that is not shifted left or right. Interesting. So that tells me so our phi is 0. So that tells me this is not shifted left or right. And so I would look and say, remember our phi is sort of closely related to whether we have a cosine or a sine graph. So we have a negative cos curve, and we know that negative cos curves, as we discussed in question 15, sort of start in the middle of two peaks. It starts at a trough. If we think about starting, scare quotes, starting being at the bottom, sorry, if we think of starting being when it passes the y-axis. So that means we know this thing is going to have a point right here because it hasn't been shifted left and right, and it's a negative cosine curve. All right, so last step is we got to deal with this period. So we know our b is pi, and our period is related to b. It's 2 pi over b, which is, say, 2 pi over pi, or 2. So our period is 2, so it's an integer period. Okay, so that means I can actually label this to be 1, and that to be 2, and that to be 3. I feel like I didn't make it big enough. So it's going to be kind of skinny, actually, I reckon. All right, so I know we're going to start here, and after a whole period, we're going to end here again. So after 2 units, we're going to end here. I can even draw it backwards, too. I know I only was asked to draw 1 full cycle, but it says at least, and I've got a little bit of extra space, so I'm going to draw both. Hey. Yeah, can you give me a minute and a half? Sure. I'm almost done. All right, and so I know in between 2 troughs is 1 peak. So it's going to come up here. So in between 2 and 0 and 1 and 0, we're going to have a peak. And then I might just go ahead and sketch the rest of this graph, looking something like so. And it's going to continue sort of like that. All right. Let me know if you have any questions. I think we're going to finish this tonight. All right.